Hello, in this short tutorial, I'm going to show you how to process data from a thermal analysis or a solidification curve on Matlab to see the different transition points in a solidification curve. So basically, the analysis that we are doing is the temperature time curve and the first derivative of the temperature. So you will see the different transition points. And also we can plot in a different plot temperature versus cooling rate. The cooling rate is basically the first derivative of the temperature. And basically, you'll see also the different transitions at different temperatures. We're going to be focusing in the solidification part because those cups are designed more for solidification curves. So basically, those cups are designed with a K-type or S-type thermocouple, K-type for low melting alloys, and S-type for high melting alloys like steels and things like that. So basically, we pour the liquid in this cup. When the metal starts to solidify, the thermocouple start to track the temperature. And we are using a software, LabVIEW software in our laboratory to save this data. You can use any other DEQ system, but basically the software just captures the data at a certain time in a text file. So we're gonna be processing this data using Matlab. So now we are in the Matlab Atmosphere software. So basically, here is the basic configuration. In the left side, the current folder where all of my files are located, the command window and the workspace. And right now it's empty. I'm going to use this software that you can find in the description. I'm going to share this program in this sharing folder. So you can find the program in the description. So basically, this program utilizes this function called data figure. But mostly the program is going to be running, the main program is going to be running by this program called plot derivative. So basically, when you download the code, you copy here in the current folder, like in a M file. And after that, you can run it. So basically, you double click here. And basically, this is the code. It's a simple code. The first thing that we need to do, there is a couple of instructions there. So this is the version 1. Probably I'm going to improve it in the future. But basically, the main things that we need to input here are where is the data located and what is the time that we are saving the data. So the first thing that we need to do, as I put it here in the note, we need to manually import the data. Now, there are ways to import automatically. In this case, we are just going to import it manually, okay? So I just copy and paste here in my current folder the file that contains all of the text file that contains all of the text data. So I can open in Matlab, but I also can open externally just to see the file. So for example, if I right click here and open outside Matlab, it's going to open the notebook, the notepad, and basically show the text, the raw data, all of the file. So basically, you'll see basically is classified here as a row, time, cup 1, cup 2. In this experiment, we captured 2 cups, 1 and cup 2. Okay. So basically, we're going to be focused more in cup 1 in this tutorial. And basically, we have the data separated by commas. So you'll see 1 is the row 1, time, comma, temperature 1, comma, temperature 2. So basically, different rows. Okay. There is here the software save the time in a time format. As you see here is hours, minutes, seconds. We are going to skip that. There is different ways to handle this, but in this case, we're going to do the simple process. So this is the external file. Notice that there also something important here is that say the scanning rate is 0.5 seconds. That's important because we need to create a time vector that must match this 0.5 value, okay? Because we're going to basically manually create a time vector instead of using this time information here. All right, so to import the data in Matlab, again, there are different ways, but the manual way is just right-click and import that. Okay, so we're going to import data, and basically a wizard window here opens where it's going to show me a process how to import the data. Sometimes it takes longer depending on your machine, but basically in this case we are just going to import and you see basically the file try to organize the data, basically discarding the first headings, and we have row, time, cup 1 and cup 2, and it's organizing automatically in a table because we have different formats of numbers. For now, I'm just interested in the cup number 1. Okay, so I'm just going to take the data from cup number 1. And I'm just clicking the first cell, and I'm going to the end, pressing Shift, and lastly, last shell. So basically, I'm taking all of the information from cup 1. You notice there. And instead of doing a table, I'm just going to save like a numerical matrix. That's important part, okay? Because numerical matrix is the time of variables that I'm going to process. All of this is numerical, so I'm going to import as numerical. And I'm going to give a name here. So basically, I'm going to change this on title bar cup 1, for example, okay? Enter. So we have cup 1, just selecting this data, and I'm going to import this numerical matrix in the Matlab Atmosphere. So when we click the import selection, we notice that there is a cup 1 variable created in the workspace. So this is the variable that contains all of the information. If I double click, you'll notice that all of these numbers are located in this matrix here. Now, notice that Matlab automatically created here my variables, but also in this other tab, there is my code that I double click here. So I have my code tab and my variables tab. I can close one of the tabs if I just want to e-code, but if I double click, it's going to open again the variable tab. Okay, so that's the first step, scope number one. It's the data is already imported on Matlab. And the next thing that I'm going to do is I'm just going to modify two parameters in the code. The first one, the data, it's the name of the data that I'm just created, which is cop1. If I imported like cop200, I need to put here 200, cop200 and so on. And the time step also is important. If you remember here, if I open outside Matlab, you remember that the time scan rate is 0.5, okay? So this time step is going to be 0.5 seconds. I can change it to 1 or 2, depending on how you are saved the data, okay? So that's also manually. Now, after that, I can run the program. So I'm going to run by sections just to show you how easy is the program. So if I in the program, I can go to editor and run the section. First section is located up to here, and the second section and the final section is just create the variables. I can run the whole program, but in this case, I'm just going to run by sections again. So I just put this data, run section. And the first thing that the program is going to do is it's going to upload my data. Notice, but it's whole data. I don't want, this is the preheating data, previous data, and after that is the interesting data. I don't want to see all of the previous data. So basically, I included in the code delete previous points, like software or code, where you click a point that you want to consider the 0, and it's going to basically shift everything and delete previous data, just to process it. The data is still safe in cup 1. Okay. So what we're going to do is, you see the cursor is activated, so I can click and it's selecting a point here. So I can move this point up and down with my mouse. I'm selecting the last point here at the top, which is basically when my curve starts. I also can click here in the zoom, and I can zoom to see more details about that point. And I can switch to the data tips to move my data tip here again. So I can select in this maximum point. And when I find with the point that I'm selected, I'm going to click enter. Okay. So after clicking enter, basically the data is created, or the code, the first section of the code is creating different variables that are used for my code. Okay. So the second part is the plotting, and basically the last part of the code. Basically, the only part that you can play with this area is this one, the filter. Basically, it's a medium filter. You can check the Matlab tutorial for that. And I'm going to comment this filter for now, but I'm going to activate it in a minute just to see the difference. Okay. So I have figure 2 and figure 3 that I'm going to create, and in the figure 2, I'm gonna plot temperature time located in the left axis, and in the right axis, I'm gonna plot time cooling rate. In the figure number 3, I'm gonna plot the cooling rate and the temperature in the y-axis. Notice that the derivative I calculated using this function in Matlab called gradient. So basically, I put the gradient between two set of numerical data, and it's calculating the first derivative of the data. So it's a pretty handy function. So let's take this section and let's run this section now. So when I run it, basically it's creating two plots, okay? So notice that we have the left side and the right side. You'll see all of this noise coming from the data. We didn't put any filter. Remember that I comment this filter here. So basically what I can do is, the figure number 2, I can click it, go view, plot browser, and it's gonna basically plot browser, and also I can type, I can go and plot editor. Okay, sometimes this plot editor is not popping up. So you just go to view and plot editor. So basically in pop editor, you can edit a little bit the plot. So manually. So basically, for example, you can take the area and create a box. You can take the Y and axis lines, but also you can change the axis, right? For example, the X-axis, I don't want to see all of this data. I just want to see up to 1,000, for example, seconds. So I just type 1,000 in the max, and I just filter in that, or for example, 700 seconds, just to see more details. And the temperature is plotting between y-axis here, the left side temperature between, let's say, 500 and 1,600. Okay. And in the right axis, we have the cooling rate. Usually the cooling rate is negative. So it started at 0 maximum and negative here. So that's the cooling rate. And I can also, put, for example, -5 there just to give it more, or -4 if I want to see more details. So you'll see how, clean, how good my data start to see. I also can change the fonts. I like to see my plots with Times New Roman, nice and big font size, just to make sure that you can see. And I can do the same with the other plot, the plot number 3 that was created. Okay, so I can modify, do everything that I want there. But what I noticed here in the figure number 2 is that there is a lot of noise. So basically, I can play with the filter a little bit. So basically, in this line 51, I can just uncomment this median filter, and basically it's doing a median filter every 10 data points. So every 10 data points, it's going to use a median filter there. So basically selecting the median value in the 10 points around the particular value that is analyzing. So if I run this, again, this section, you're going to notice that now we have, similar data, but we have more plots here. So basically notice the first plot here, it's the time, temperature time, so it doesn't look too different. But when I open the first derivative in the first one and the second, you notice that the first derivative in after filter is much smoother because, we are producing this filter. So I can basically use this one. And by the way, I can change the type of foam here, the type of lines. Oh, sorry. By selecting these two, I can select the type of lines, and I can also make it bigger. So for example, like that. Okay. So basically, I can see here clearly all of the transition points. And as I mentioned before, basically here a phase transformation occurs approximately at 700, but we are not interested in the solid phase transformation. We are more interested in solidification part. So I can filter more in this area. So I can select the y-axis and go into, for example, 200 seconds. So notice that we have the more closer view of that. And I also can manually, filter the y-axis here. So for example, between 1000 and 1600. So basically clear, you'll see here there's the solidification cup start, and I can create this data tip. Okay. Solidification point start and the blue line. So when this derivative change approximately this value, we have our liquidus point. So the material start to solidify. So that's the liquidus. The liquidus start to form. We have a particular, kind of thermal arrest or so. We have a small bump here that could be a small phase transformation, but mostly our liquidus temperature start approximately at this point when this derivative change. So basically, we're saying that the liquidus was approximately at 1475 and the solidus approximately at 1439, 1435, something like that. So this is a pretty good way to check the data. So after that, I can just go to edit, copy my figure, and it's ready to paste on your presentation or your document. Okay. Same with the other one. So basically, I have here two plots, as I noticed. The first time that I did the first derivative is too noisy, so I'm just gonna use the second one, and I'm gonna change a little bit this, make it this figure a little bit fancier, big fonts, doing the white more. And I also can filter, the y-axis. So y-axis go to 0 to 4 in this case, and the y, let's say, to 400 to 1500. So you'll see different transitions there at different temperatures. So this is a different way to see the data, but that's the most important part here in this case. So, so in this tutorial, we were able to basically take the experimental data that we took from the S-type cups and plotted the temperature time with the first derivative and plotting the first derivative versus temperature in the second plot using the code that is shared in the description. Please let me know any comment.